You wrote that at the age of 13, you were first exposed to plane geometry and was wonderstruck by the power and elegance of formal proofs. Are there problems, proofs, properties, ideas in plane geometry that from that time that you remember being mesmerized by or just enjoying to go through to prove various aspects?
So Michael Rabin told me this story about an experience he had when he was a young student who was tossed out of his classroom for bad behavior and was wandering through the corridors of his school and came upon two older students who were studying the problem of finding the shortest distance between two non-overlapping circles. And Michael thought about it and said, you take the straight line between the two centers, and the segment between the two circles is the shortest, because a straight line is the shortest distance between the two centers, and any other line connecting the circles would be on a longer line. And I thought, and he thought, and I agreed that this was just elegant. The pure reasoning could come up with such a result.
Certainly, the shortest distance from the two centers of the circles is a straight line. Could you once again say what's the next step in that proof?
Well, any segment joining the two circles, if you extend it by taking the radius on each side, you get a segment with a path with three edges, which connects the two centers. And this has to be at least as long as the shortest path, which is the straight line.
The straight line, yeah. Wow, that's quite simple. So what is it about that elegance that you just find compelling?
Well, just that you could establish a fact about geometry beyond dispute by pure reasoning. I also enjoyed the challenge of solving puzzles in plane geometry. It was much more fun than the earlier mathematics courses, which were mostly about arithmetic operations and manipulating them.
Was there something about geometry itself, the slightly visual component of it that you can visualize?
Yes, absolutely. Although I lacked three-dimensional vision. I wasn't very good at three-dimensional vision.
You mean being able to visualize three-dimensional objects?
Three-dimensional objects or surfaces, hyperplanes, and so on. So there I didn't have an intuition, but for example, the fact that the sum of the angles of a triangle is 180 degrees is proved convincingly, and it comes as a surprise that can be done.
Why is that surprising? Well, it is a surprising idea, I suppose. Why is that proved difficult?
It's not. That's the point. It's so easy, and yet it's so convincing.
Do you remember what is the proof that it adds up to 180?
You start at a corner and draw a line parallel to the opposite side. And that line sort of trisects the angle between the other two sides. And you get a half plane which has to add up to 180 degrees. And it consists, and the angles by the equality of alternate angles, what's it called? You get a correspondence between the angles created by the side along the side of the triangle and the three angles of the triangle.
Has geometry had an impact on, when you look into the future of your work with combinatorial algorithms, has it had some kind of impact in terms of, being able to, the puzzles, the visual aspects that were first so compelling to you?
Not Euclidean geometry particularly. I think I use tools like linear programming and integer programming a lot, but those require high-dimensional visualization, and so I tend to go by the algebraic properties.
Right. You go by the linear algebra, and not by the visualization.
Well, the interpretation in terms of, for example, finding the highest point on a polyhedron, as in linear programming, is motivating. But again, I don't have the high-dimensional intuition that would particularly inform me, so I sort of lean on the algebra.